Okay. Hi, everybody. Welcome to my kitchen and welcome to Spring Science. I hope you're all ready to learn something new and to have some fun. We're going to be doing 4 activities today that are going to help us understand how plants drink, how rain happens, what lightning is made of, and what wind is. So before I start, I want to mention that I am in Oshawa right now, which is on the traditional territory of the Mississaugas of Scugog Island First Nation and is covered under the Williams Treaty. Today is the vernal equinox, which is a significant day for many First Nations across Turtle Island or North America. And today is a reminder of new beginnings, self-reflection, and all that Mother Earth provides for us. So I hope that you will join me in taking a moment to reflect on the history of this land and the meaning of today. So has anyone heard of an equinox before? All throughout the year, the Earth tilts a little bit. So it's a little bit like this, or maybe like this. And that means that in some places, the sun shines longer than in other places. So that's why in the wintertime, our days are shorter, and in the summertime, our days are longer. Today is the spring or the vernal equinox, which means that the Earth is standing straight up like this. So everywhere, all over the world, the daytime and the nighttime are the exact same length. And for us up in the northern hemisphere, which is up here, it means that the days are going to start becoming longer and the nights are going to start becoming shorter because it's springtime now. So until the fall, when the next equinox is, our days are going to get longer and longer and longer. So in the southern hemisphere, it's actually the opposite. So on today, the equinox, it's actually their fall equinox. So as of today, their days are going to start getting shorter and it's going to be their fall time. And then in September, when the next equinox happens, it's going to switch and it's going to be their spring and our fall. So I think that's pretty cool. And I think that is a really good reason for us to be talking about nature and springtime today when we're doing some science. And I also wanted to mention that the spring equinox is really important for culture as well, not just because the Earth is tilted. So there are people with celebrations all over the world. There's people in Japan, Afghanistan, Turkey, India, Egypt, China, Mexico, all over the world, including Canada with some First Nations who celebrate the spring equinox, because it brings us new beginnings, new life, and extra light. So celebrations today usually involve lots of colors, foods like maple syrup, and vegetables that are growing around this time, families sharing their love, and people reflecting on all that nature gives to us and maybe what we can do better for nature. So to start off our spring science today, we're going to start by talking about plants. Plants need water just like us, but they can't drink it from a cup like we do, right? So they use their roots, which are little stringy bits right at the bottom, to drink water. And they don't do that with a straw sort of action like we might think. They actually have a special material that their roots are made out of that sucks the water up. And we're going to do an experiment that shows us how that happens. So what you're going to need for this one is, hold on one second. Here we go. You're going to need 6 different glasses, about the same size, but they don't have to match just perfectly like mine. They don't match. And you're also going to need some water. Tap water is totally fine. You're going to need some food coloring. Red, yellow, and blue work best, but if you have other colors, that's okay too. You're also going to need some paper towels or paper napkins and some scissors. So first, we're going to start by arranging our glasses in a circle like I've done here. And then we are going to, in every second glass, so in this one, in this one, and in this one, make sure that there's an empty glass in between each glass. We're going to put some food coloring. So for red and blue, the food coloring, maybe 15 to 20 drops. And for the yellow, you're going to want to do a little bit more just because it's a lighter color. And I just wanted to mention, if anyone has any questions, just let me know. We have got a chat box and we've got a question and answer box. So you can just type that in there and I will do my best to answer. So once we have our food coloring in every second glass, we're gonna get some water. I'm just gonna get some from my tap. And we're gonna pour it into our cups so that they're about 2/3 full. So a little more than halfway, just like that. And we'll do that for each of the cups that has food coloring. So make sure that the cups with no food coloring are empty. So there we go. So we've got our 3 cups with empty cups right in between them. So there's no 2 full cups beside each other. So our next step is just to mix. Make sure that the food coloring is all mixed in. And there we go. So once your food coloring is mixed, I'm gonna take some paper towel or some paper napkins if that's what you have. And you're gonna cut strips out of your paper towel, maybe 2 or 3 fingers wide. And you're gonna need 1, 2, 3, 4, 5, 6 strips so that you can have 1 strip going between each set of glasses. So there'll be 2 in each glass. Okay, so you should have 6 paper towel strips that look like this. And what we're gonna do is we're going to place them inside one of the cups with food coloring and then place the other end into an empty cup, the one right beside it. And what you're gonna start to notice already is what we call capillary action. So the water from the glass with the food coloring is creeping up the paper towel. And that's actually what happens in roots. So if I were to dip a really big plant root into this glass of water, it would do the same thing that this paper towel is doing. It would suck the water up and into the plant, which would be the other glass that we're doing right now. So for this experiment, you can see the results right away, but if you leave it for a little while, check on it maybe later tonight, after you put all of the paper towels between the glasses, you're gonna find that there's actually gonna be water in these empty cups. It's gonna bring water from these cups with the food coloring all the way into the empty ones. And if you leave it long enough, eventually all the cups will have the same amount of water, which I find really cool. And hopefully with the food coloring, you're gonna see a fun rainbow pattern. So your cups should look like this now with lots of paper towels in between. And if you want to take a look, you should see some food coloring and some water traveling and making its way. I see my red one is doing it right now, making its way across, up and over. So it's actually climbing all the way up the paper towel and going into the next cup, which I find very cool. So with this experiment over for now, we're gonna set it aside and hopefully later tonight or this afternoon, you're gonna be able to see a really cool rainbow in all of your cups. So thanks for joining me for that experiment. Our next one is gonna be about rain because we can't talk about water and plants without rain, right? So rain is the way that the earth recycles its water. Did you know that the water on Earth right now is actually the same water that was on Earth when there were dinosaurs? I think that is pretty wild. So we actually don't get new water and we never get rid of water. It's always on Earth and it always recycles itself within our atmosphere. So the Earth does this by taking water that is on the ground in lakes or ponds, rivers, even in puddles. And that water turns into an invisible water vapor that we can't see. And it's super light, so it floats all the way up into the sky. And once there's enough water vapor, that vapor starts to make clouds. And that's what we see up in the sky. I don't know if there's any today, but on a lot of days you'll see white clouds, and that's actually all water. So once a cloud gets super full of water, usually it turns gray when that happens. And if it gets so full that it can't hold any more water, that's when it starts to rain. So the water that's come from the ground in puddles or ponds or lakes has floated all the way up to the sky, filled up the clouds, and now the clouds are raining it back down. And since it's only water that will float up into the sky, the water that comes down is usually clean, which is how we recycle our water and have the same water for millions and millions of years. So our next experiment, we're going to see that recycling happen in fast forward, which is going to be very exciting. So what you're going to need is a clear glass. You're also going to need some plastic wrap, and you're going to need some hot water. If you have a kettle, that would be great. But my young scientists, if you have an adult assistant, now would be a really good time to ask them for some help, just to keep yourself safe from the hot water. And you're going to need some ice cubes. So I'm going to turn my kettle on right now, and we're going to wait for that to boil. And I'm also going to grab myself some ice cubes from the freezer. Okay, so while our kettle's boiling, our first step is going to be to take some plastic wrap that it's going to be enough to cover the top of the glass. And if you'd like to measure it and cut it into a square, that's totally fine. And if you'd like to just leave it, that's fine too. Now, since we're going to be using boiling water, it's really important that we warm up the glass first. So if you've got a tap with some hot water, it'd be a good idea to fill your glass with some tap water that's hot before putting boiling water in so it doesn't crack. And as for our kettles to boil, if you guys want to think about what might be happening with this experiment, now would be a good time to imagine that. So when we boil water, what happens with that? What do we see that like comes up? I wonder. And I wonder what that might have to do with what I explained about the water cycle. I think water vapor might be something important. So my kettle is just about boiled. If you have oven mitts or a tea towel, that might also be something good to grab right now. And as my kettle turns off, I'm going to pour my hot water into the glass. So you're only going to need it about to here, so a little bit less than halfway. So I'm going to pour my hot water into my glass and really quickly put my plastic wrap on top. So young scientists, now would be a good time to ask your helpers to put some plastic wrap on the top of the glass because it's going to be hot. So make sure not to touch the glass. So I already see some cloudiness happening on the glass. Does anyone else see that in their glass? So this is water vapor. The cloudiness that you see on top and on the side, that's water vapor. It's getting hot. So usually the sun will do that to water on the ground. But right now it's getting hot and it's putting water vapor on the sides of the glass. So if you guys have some ice on hand, put your ice on top of your glass on the plastic wrap and let's see what happens. And if you have any guesses, now would be a good time to think about those guesses of what's going to happen. I'll give you a hint. Something important to look at is going to be the underside of the plastic. So if you want to sort of flatten out your plastic really carefully and maybe lift a little bit up so that you can see. This one takes a little bit. So we're just going to wait a couple minutes and see what happens. Now on my glass, I see some big drops of water vapor forming underneath my ice. I don't know if anyone else sees that, but I'm seeing that right now. And I think that as the water vapor droplets get bigger and bigger, that's going to turn into rain. I think I saw someone comment that. So I think it's going to turn into rain. What do you guys think? So this is actually what happens when it rains outside. So what the sun will have done is made the water on the ground hot, maybe not as hot as a kettle, but it will have made it warmer, and it will evaporate up into the sky like it's doing here, all this water vapor, and cause some clouds. This ice just speeds up the process. And then if you watch long enough, it should drip down off the bottom. And that's actually what a rain cloud does. So when there's so much water vapor up in the sky that the clouds can't hold it anymore, there's nothing more that they can carry, then it drips down back onto the earth, and that's rain. So if you guys want to keep this off to the side and take a look at it, or maybe someone's already getting some rain, that would be super cool. You can also take your ice off and see what's up there. I've got, whoops, oh, I actually just got a drop. So if you want to tap on here, that will make some drops happen as well. Oh, I think I might be out of drops. Oh, there's one more. Okay. So once you guys are done observing your glass of rain, make sure to take your oven mitts and carefully move your hot glass to the sink or somewhere else to cool down. So thanks for joining me for that experiment. Our next one, our third experiment, we are going to talk about how lightning works. So when we see lightning, it's actually just static electricity. Has anyone heard of that? So static electricity is what happens when water molecules in a cloud bounce around and hit each other. So like we talked about with the rain, the water molecules up in the cloud, there's so many of them, they start to bounce around and they hit each other. And when they hit each other, that creates static electricity. So just like if you've ever touched anything, usually metal, and you've gotten a little shock on your finger, it's the same idea. So when you get that little shock on your finger, that's static electricity. So when you've been walking across a carpet with socks on, or maybe the arms of your sweater have rubbed against your sides, that is like the water molecules in a cloud rubbing together or bouncing against each other when there's so many of them up there. And that brings a lot of energy. So when your body can't store any more of that energy, it wants to transfer it somewhere else. So say I touched my sink over here, which is metal. If my body has a lot of energy in it from my arms rubbing against my sides or my socks rubbing against a carpet, that energy is going to transfer to the metal so that my body can have some less energy because it can't hold anymore. So I'll touch it, and the shock that I feel is actually the energy moving. So it's not something coming up and biting you or something poking you, it's energy moving out of your body into the object you've touched. So in a cloud, it looks a little bit different. The energy will get really heavy, the cloud can't hold anymore. And when it really can't hold any more energy and it wants to get rid of that energy, it sends it down to the ground where we are. So lightning is really just a lot of static electricity. And what we're going to do to demonstrate that today is we're going to make our own little fake lightning. So we're going to need a blown up balloon, some tape, some tissue paper, and some scissors. So I've prepared this a little bit ahead of time. I've got my strips of tissue paper with some tape on the end. So I'll give you guys a minute or two to cut a few strips of paper. I've got 3 strips of tissue paper, but you can do as many as you'd like, and then tape them down to your counter. So once you've got your strips of paper, don't worry, I'm not moving on yet. So you can still keep cutting if you need to. We're gonna take our balloon, and if you need to blow that up right now, go for it. So we're gonna take our balloon, and what you're gonna do is you're gonna find either some fabric, usually wool works best. I might use my oven mitt, I might use my shirt, and the most fun way is to do it on your head, on your hair. And you're gonna rub your balloon on your hair. And what that does is makes a whole bunch of energy in the balloon. So just like when a raindrop hits into another raindrop in a cloud, we're going to be hitting our balloon raindrop onto our head or our shirt's raindrop. And what that's gonna do is create a bunch of energy. And we're gonna keep doing that so that the balloon has a whole lot of energy, that it has enough to give away. And you can kind of see already that my hair is sticking a little to the balloon, and you might see that your hair gets really big, or it might stick to your balloon and poke right straight up. And if you're doing it on your shirt, you might see little fluffs on your shirt starting to stick up and go towards the balloon. It might take a little bit, so just be patient. Okay, so my hair feels a little funny. So I think it might be ready. So what you're gonna do with your tissue paper is we're gonna put our balloon right on top of it, and we're gonna see what happens when it gets really close. Is that happening for anybody else? Your tissue paper sticking up or going towards your balloon? See if you can get more than one. Oh, there we go, I've got 2. So what's happening here is that the energy from our balloon or our raindrop or cloud is transferring to these pieces of tissue paper. So when we do this and our tissue paper attaches to our balloon, right here, this is energy transferring. Right in here is energy. So our balloon is so full of energy, it's got lots to share, and it's giving some to this tissue paper and go heading towards the ground. So if this were a cloud, this would be our lightning bolt, this tissue paper. So all the energy from our cloud is traveling down through the tissue paper into the ground or my counter. So really, lightning is just the same sort of electricity we can make ourselves with our own bodies in a balloon, but it's so much more. It's so much bigger that we can actually see it. And when we see it, we usually also hear thunder. Thunder is actually just the sound of lightning. So I don't know if any of you, when you were rubbing it on your head or on your shirt, if you could hear sort of crackling noises or sort of fuzzy noises, that is what thunder would be in a rain cloud. So when all of that energy gets stored up and then it transfers down into our lightning, there's going to be some sound because there's so much of it, and that's thunder. Thunder is so loud, there's so much energy moving from the cloud into the ground. Let's see if this will work. Oh, nope, I've lost all my energy. Have to make some more. But all that energy moving down is really just the lightning, and then the thunder is the sound of that energy moving. So my experiments are going a lot quicker than I thought they would today. We're also going to be posting this on the YouTube channel, and you guys can watch it back and play it again. If I'm going too fast, you don't have time to see your experiments, that's totally okay. Then you can go back and get some more instructions and try it again. Make sure to pause and play and rewind as much as you want. So we're going to move on to our very last experiment, which we're going to talk about wind. And wind is actually just air that's moving. So this happens when the temperature of the air changes. So cold air is heavier than warm air. A little bit funny, we don't usually think of air as having a weight, but it does. So cold air is a little bit heavier than warm air. The warm air is actually light enough to move up higher into the sky. And when that happens, there's going to be a little extra space down here. So if the warm air moves up, this is going to be empty. So when cold air comes from somewhere else to fill in this gap, that is how we feel winds. So when we feel wind, that's really just cold air moving in to fill in an empty space. And usually we can't see wind, right? We can usually only feel wind. But when we have an object that moves with the wind, sort of like a pinwheel, then we get to see it instead of just feel it. So what we're going to do today is make our own pinwheels just like this so that we can see the wind. We can see how fast it's going, maybe where it's coming from or what direction it's going, instead of just feeling it, which is how scientists measure the wind. They use more scientific objects than just our pinwheels, but they use objects similar so that they can see the wind and they can measure how fast it's going. That's why we measure wind in kilometers an hour, because we measure what it looks like when it's moving through an object. So what we're going to need for this experiment is an unsharpened pencil with an eraser. I don't have any unsharpened pencils, so what I've done is actually taken some tape and covered the sharpened part, just because it's fun to wave these around and I wouldn't want anyone to poke somebody or themselves by accident. So make sure to cover any sharp point that you have on your pencil with some tape. You're also going to need a pencil to draw with, a push pin. I am using a swing pin. I don't know if you can actually see it. I'm using a swing pin today because that's what I've got, but you can also use those ones that you use on bulletin boards as well. You're also going to need half a piece of paper. So if you've got printer paper, you're going to want to cut it in half, just like this. You're going to need some scissors, and you're going to need a ruler if you have one. So first, we're going to make our half piece of paper into a square. So how we're going to do that is we're going to take this sort of side piece and bring it up all the way up onto this top. So it's going to look sort of like a triangle. I'm going to do it on the counter and then lift it up to show you. It's going to look a little bit like this, like a triangle. And don't fold it. We're just going to hold it like this. And you see this part over here, we're going to cut this off. So if you can mark with a pencil on your paper where that point is, where when this is all flat against each other, this is the leftover. So I drew a point right here. You can continue that point in a straight line with your ruler. And if you don't have a ruler, just try your best to cut a straight line, and that's okay too. It doesn't have to be exact to work. I'm just going to cut my extra paper off. And now you should have a square piece of paper like this. So next, we're going to take our pencil. You can use your ruler for this part if you like, but you don't have to. You're going to find about the center of the paper, which I think is probably right here. And you're going to draw a dot. Just like this. And then once you have your dot, this is the part where a ruler might be helpful. You're going to take your ruler and draw a line from each outside corner towards the dot. just like that, but you're only gonna go a little bit past halfway, not all the way to the dot, just a little bit past halfway. So I'm gonna draw my lines and I will show you what it looks like. Okay, so I drew my lines a little bit past halfway, not all the way so that it's touching the dot, but just part way. So while you're drawing those lines, start thinking about what you might want your pinwheel to look like. So I've got some nice little dots on mine here. So on the side without any markings, so the blank side, you're gonna take some markers, crayons, whatever you like, and draw a really quick little pattern. It can be stripes or dots, flowers, whatever you feel like. I think I'm gonna go with some purple flowers. Okay, so far mine's looking like this. I'm gonna put another color, I think. So if you guys are still drawing your lines or drawing your pattern on the back, keep going for that. Let's go with some orange. Okay, so hopefully you guys have finished up your patterns. If it's not perfect, that is okay. We are gonna have the instructions posted. You can go back and make another one if you'd like to. So now that we've got our pattern, on the side with the markings, you're gonna take your scissors or ask your adult helper to take their scissors, and you're gonna cut down this line that you drew. Make sure not to go all the way, just a little past halfway towards the dot. So now what you should have is a square with 4 little flaps like this that sort of look like triangles with no points. So next, what we're gonna do is we're gonna take one of the corners of each flap and we're gonna fold it sort of into the center. We don't have to fold, just sort of bend. We'll bend it into the center like this. And then I'll take this second flap and bend it into the center like that again. Might be a little bit tricky. It'll take you a couple tries to get them all to stay. But we're gonna keep doing one side, the same side for each flap into the middle like this. And make sure to hold the flaps in place as much as you can. And then we're gonna have our pinwheel. Now, very carefully, we're gonna take our push pin or our sewing pin and we're gonna poke it through the middle. Make sure that your finger is not on the back because it might come through a little fast and it might poke you. So make sure to move your finger away from the back if it's possible and just protect yourself from getting poked. And if it takes a few tries, that's totally okay. It's a little tricky to get it through and make sure that all the flaps are also held by it. Let's see, did I get it? I think I did. So now when I push my pin all the way through, I should have a little pinwheel that looks like this. And I'm just holding it in the back here. But our next step is we're gonna get our pencil and we're gonna poke it through the eraser at the end of the pencil. Now, again, make sure your finger isn't right at the back of the pencil or ask an adult for help. So I'm gonna poke it right through the pencil. I'm not sure if you can see because it's pretty small. But I'm gonna push it as far as I can through the pencil, just like this. Now, this is the part that's going to take a little bit of adjusting. So you might have to pull this center pin out a little bit until your paper can spin. So mine can spin right now. Not quite if I blow on it though. So I'm going to move it out a little more. Might also have to twist it a little bit just to get it to move. Okay, there we go. So mine is in the right spot. So now that it's in the right spot, I'm going to take another piece of tape and I'm going to stick it on the back. A, so that I don't poke myself with the pin that's sticking out, and also B, so that it doesn't move. Because we don't want our pinwheel to fall apart, but we want it to be able to move. We don't want it to be too tight. So just wrap it around the pin at the back as well as you can. So that's going to protect us while we are running around with our pinwheels outside, and it's going to protect anyone around us. And it's also going to stop our pinwheel from falling off our pencil. So there you go. Now you've got your pinwheel. And I think today, at least where I am, it looks like a really nice sunny day. So it would be a great day to go around and see if you can make your own wind by running fast enough, or if there's wind outside, to see how fast it's going and maybe which direction. So thank you so much for joining me for all these activities. I realize we're ending pretty early. So I would love to see questions, or if you'd like me to redo an experiment so that you can see it again or see what the instructions were, I would love to do that. So if anyone has any questions, type them in the chat box or into the question and answer. I see someone asking for the rainbow one. Mine right now is not done yet. So when I tested this out a couple weeks ago, it took quite a while. So if you guys have done this experiment at home, it might take until tonight or maybe even tomorrow for you to see exactly what happens. But what's going to happen, so here I've got my blue and my yellow. What's going to happen is eventually the yellow and the blue are going to make their way all the way into this glass and mix together and make some green water. So that's going to happen with all of them if you leave them long enough. And what let that happen was the capillary action we talked about, remember? So with the paper towel, it's actually all wet already. So the dye is coming all the way up and going over down into here. And that's exactly what happens with a plant. So inside this little pot, there's roots that aren't actually paper towels, but they do the same sort of thing. So it's sucking up any water that I put into the dirt and bringing it up into the rest of the plant, which would be this cup. So thank you for that question. Hopefully your experiments will turn out and you'll be able to see the full final effect with all the mixing colors and all of those wonderful things happening. So if anyone else has any questions about the science that we've done today, about wind, rain, we've also done lightning, and we've done how plants drink. If anyone has any questions about those, please let me know. And if you have any questions about the equinox, which is today, let me know as well for those. And if you've asked a question previously, I can't actually see it. So if Nicole, you could run through those questions and let me know if there are any. Yeah, so that's all the experiments I've got today. So if anyone has any questions, please type them in and Nicole will read them out for me. Okay, perfect, no questions. So that's all I've got for you today. I know I've ended a little bit early, but please feel free when we've uploaded this video to go back and do the experiments again. Thanks so much for joining us. Happy equinox. Make sure to spend some time outside today. Have a great day.